Hello friends, here we can discuss about the characteristics and applications of series wound generators. Okay, as the name indicate, series means the field windings, armature windings and the external loads. These three things are in series. You can see in this figure. Okay. Due to this reason, the current flowing through the armature will be same as that of the current flowing through the field and the current to the load. These three currents will be same. Okay. IA will be equal to ISA will be equal to IL in the case of series wound generator. And mainly there are three characteristics are there. First characteristics is open circuit characteristics. The second one is internal characteristics and the third one is external characteristics. Okay. The open circuit characteristics is also known as magnetizing characteristics or no load characteristics. That will give you the relationship between the no load voltage, that is E0, and the field current IF. Okay. In the case of this open circuit characteristics or no load characteristics, no load means these portions will be absent. Means IL equal to 0. If it is open, then it is possible. What will happen? If IL equal to 0, then IAC will be 0 and IA will be 0. So practically it is not possible to plot the open circuit characteristics of a series field generator. Okay. But theoretically we can do it by separating its field windings from the generator and which is excited by the external DC source. You can see here the field windings are excited from here and it is excited by the field windings are separated from the generator and it is excited from the external DC source. Okay. Experimentally it is not possible, but theoretically we can say that we can do it. Okay. In this waveform, in this graph we can see three characteristics. Okay. Here A, B and C. Curve A represents open circuit characteristics. That is the first characteristics. Open circuit means the load is absent or load is not connected there. And it will give you the relation between E0 and IF. If the field current increases from 0 to a particular or a maximum value, no load voltage will generate in the armature, but it will not start exactly from this 0 due to residual magnetism. Okay, in each and every generators or motors or whatever it is, there will be some residual magnetism. Okay, due to the residual magnetism, the generated voltage, it will not exactly starts from this 0, but it will start from the point D and the path will be D, E, F, G and okay. So from the point D, we can note that the graph is linear up to the point F, because the rise in field current, we know that the rise in field current will increase the production of EMF in the armature and there will be some magnetic reluctance that is very negligible up to the point F. But after that, due to this reluctance of the core, the graph will try to bend. Okay, from F to G, the graph is bending like this, and from the point G, graph is a constant. constant straight line. Why? It is because at the point G the core get saturated due to rise in magnetic reluctance, and after this point G the rise in field current will not increase the production of EMF in the armature. Okay, that is the main point about the open circuit characteristics. Next we can discuss about the internal characteristics or total. It is also known as the total characteristics of series wound generators. That will give you the relationship between the generated voltage and the armature current. And remember that the internal and external characteristics are the load characteristics. Okay, for this we can use this experimental setups. So the internal characteristics, we can see the internal characteristics include the voltage drop due to armature reaction. Demagnetizing effect of armature reaction is considered. Demagnetizing effect of armature reaction means if the load increases, the corresponding field current and the generated EMF IA will increases. Due to increasing this IA, okay, due to increasing the IA, armature reaction will increase. Okay, due to armature reaction is the effect of armature flux on the main flux. Okay, so the main flux will get demagnetized due to the armature current, so that the terminal voltage will slightly decrease. Okay, so the voltage appearing across at the terminals of the armature will decrease due to the effect of demagnetizing effect of armature reaction. Okay, so that the graph will be just like below or lie below the open circuit characteristics due to the voltage drop of armature demagnetizing effect. Okay, so the internal characteristics B will be here, and just below the open circuit characteristics due to the loading effect, again due to armature reaction, and that is the internal characteristics. Okay, the third we can discuss about the external characteristics. The graph C will show you the external characteristics, and that will give you the relationship between the load voltage and the load current. Okay, V and IL. These external characteristics include one more drop, voltage drop due to armature and field resistance. Here we can see that VL will be equal to E minus IARA plus IAC RSC, but we know that in series generators IA will be equal to IAC will be equal to IL, so I can write it as E minus IA into RA plus RSC. So due to the resistance of both armature and series field windings, there will be some voltage drop. Okay, in addition to the voltage drop due to armature demagnetizing effect. Okay, so that the graph will be like this, just below the internal characteristics. This external characteristics will be below the internal characteristics, and the internal characteristics will be just below the open circuit characteristics due to these voltage drops. So internal characteristics includes voltage drop due to armature reaction and voltage drop due to the field and armature resistance, winding resistance. Okay, so we can say that external characteristics will be the relationship between, we can see here, E0 Vs IA will be the open circuit characteristics, EG Vs IA will give you the internal chara, and load voltage with the load current will give you the external characteristics. Okay, and important point is that if the load current is increasing, you can see here, if the load is increasing means if IL is increasing, you know that IL equal to ISC equal to IA equal to I in series wound generators. Okay, if IL is increasing means if the load is increasing, definitely ISC or IF will increase, and correspondingly generator will try to generate more current so that IA will increase. If IA increase, definitely armature reaction will drastically increase. Okay, armature reaction drops will be very excess. When the load increase, series current will increase and corresponding IA will increase. Due to increasing this value of IA, armature reaction will increase. Okay, due to the increasing this armature reaction, what will happen? The terminal voltage will dropping, and at a particular moment it will reach us to zero. The terminal voltage will reach us to zero. Okay, why? Because if the load increases gradually, and if the excessive, if it is very high, if the load currents are very high, then that will definitely increase the armature reaction and the corresponding terminal voltage will decrease, because the terminal voltage is depends on the armature reaction and voltage drop due to resistance and field resistance, but these drops will be almost constant. But armature reaction is mainly depends on the load current. Okay, load current means here armature current. Okay, so we can say that the rise in load current will leads to decrease the terminal voltage, and finally it may reaches to zero. And definitely we can say that it is not suitable to use this series wound generators as a constant voltage source. Okay, because the voltage will reaches to zero, depends on the load, so that the series field or series wound generators are not suitable to use as a constant voltage source. But we can say that the series wound generators are constant current source. Okay, based on these concepts, we can discuss about the applications of series wound generators. Okay, due to these dropping characteristics, these voltage dropping characteristics, we can use it as a variable voltage generators. Okay, or otherwise we can say that this type of generators can be used as a constant current source. Okay, and by supplying the field excitation currents in DC locomotives for regenerative braking purpose, and it can be used as the boosters in feeders for various types of distribution systems like railway service in order to compensate the voltage drop in the feeder. Okay, and in series arc lightning purpose we can use these generators. Okay, these are the major area of applications of this type of generators. Okay, thank you.